Yep, and we are live. Um,
Perfect.
Welcome back to the third stream, maybe because if we count office hours as well. I
Yeah.
hope, yeah, and I hope most of your queries are answered already. But if you still have some queries, well, this would be the last webinar of today. Utilize this chance to ask all your queries. Um, and before that, the last since this is the last webinar, and Kestra has also launched on Product Hunt. Make sure you check out Kestra on Product Hunt. If you like the product, just share your views on Product Hunt. You'll find all the relevant links in the description. Registrations are open till the end of the hackathon, so if you haven't already registered, make sure you register. And now let's jump into the webinar. Well,
Perfect. Well, thank you very much for the introduction. If this is the first time joining the webinars today, my name is Will. I'm a developer advocate at Kestra, and I'm going to hopefully help you learn a little bit more about Kestra, where it fits into the tech stack, and how to use it. Now, as mentioned, we are launching on Product Hunt today. So if you think that you've had a good time using Kestra or think it's a cool bit of software, then we'd really appreciate both you to leave a comment and to upvote us on Product Hunt. As you can see, we're number 2 today currently. Let me give that a refresh, see if maybe we're number 1. Not quite. Looks like we're got quite a lot of work to do to get past number 1. But again, we'd really appreciate any support we can get. So yeah, really appreciate that. Now, today I am going to be walking you through. So earlier today, we talked about getting started with Kestra, the building blocks around Kestra. What is Kestra? Now, I'll give you a quick recap on what is Kestra, and then we'll move on to today's subject, which is how to integrate your code with Kestra. So how to write any language inside of Kestra, and 2, how you can make that dynamic, flexible, get data in, get data out, and so on. So to begin with, what is Kestra? Now, Kestra is this platform that allows you to orchestrate your code. Now, you're probably wondering, what is orchestration? Now, the example I used earlier, which I quite like, is that think of like an orchestra in music. You've got a bunch of different instruments. You've got violins, you've got cellos, you've got piano, you've got flute. And they all come together thanks to a composer who will stand in the, or conductor, sorry, who will stand in the middle and who will orchestrate them all together. That's kind of what Kestra is. The best way to think of Kestra is Kestra sits in the middle of all of your code. You've got pipelines, you've got front-end applications, whatnot. Kestra can receive all of that data. You've got databases. Kestra can receive all of that, and it can keep it all in parallel. Another good example would be, without that conductor, you could have a really, really nice flute player, and you could also have a really nice violin player. And without the conductor, they're going to make noise. It's not going to be very nice noise at the same time. The conductor allows them to work in unison. And that's sort of the beauty with Kestra. You could have a data pipeline and a DevOps pipeline. One of them's building your code and deploying it on EC2s on AWS. The other one is processing some data in Databricks, whatnot, doing an ETL pipeline. Now, that's great and all. Maybe you want them separate, but maybe you want them to be able to communicate with each other. Basically, maybe you only want your code to deploy once data is in process, and vice versa. And that is kind of where orchestration comes in. Now, to sort of give you some examples to help you understand where it would fit in, common use cases include data orchestration, so processing data pipelines and so on. If you've got loads of Python scripts and you want to be able to run them with lots of different data inputs, orchestration is great for that, because you can run the same Python script loads, but you can hand it different inputs every time it runs. And then you can capture its outputs too and do powerful things with that, which would be a little bit harder if you're just manually running it in the terminal with a cron job. Another way to think about it is like a CI/CD pipeline. So GitHub Actions, Jenkins, all of these sort of things that are designed that when you push to GitHub, maybe make a pull request or you merge to your main branch, that they start building your code and deploying it to the cloud into production. Maybe they run unit tests. Again, Kestra is really well designed for doing that too. Thank you so much for giving us an upvote. I really appreciate that. So hopefully that gives you a bit of an overview of what Kestra is. Now, I've had the question all day, what can I do with Kestra? Now, you can build whatever you like, but I'm specifically going to show you how you can use Kestra as sort of a framework around your code, right? I can write Python code and I can run it with my terminal by just typing Python and then example.py. But Kestra will give me an interface to do that. It gives me a UI, gives me some validation on what inputs I can hand it, whereas that's a little bit more fiddly by using the terminal. So let's jump in with an example. So here I've got a flow called my flow. Now it's all written in YAML. At the top here, we've got my flow ID, which is called my flow. We've also got my namespace here, which is company.team. Now, my flow ID is unique inside of the namespace, and you can think of the namespace a bit like a folder. It's where I'm going to organize my flows. So all of my flows are in the company.team namespace. And actually, we can see here, I've got a bunch of different ones, but I could put them in different namespaces if I wanted to. Maybe I want to put all of my data ones in one place, all of my DevOps ones in another place. Just makes it a little bit easier. So with that in mind, what we will do is go back to our my flow. After we've got our ID and namespace, which are mandatory for every flow, we also have a block called tasks. Now, this is where the magic happens. This is where all of the magic of our flow is going to take place. Now, this flow is very simple. It's simply going to log a message to the terminal, just saying, hello world. And if I was to run, a Python script like this, I'd have to write it in the terminal, press run. Here, I can just press this execute button, press execute. And as you can see, it's executed my log message. I can see it here really nicely in my terminal. Very nice. Now, let's get rid of that. We do not want to write a log message. That's not very helpful, not very impressive hackathon project. Someone asked, can I explain what a namespace is again? Absolutely. So namespaces are simply like folders on your Kestra instance. If you have lots and lots of flows, you can use those namespaces to help you organize where all your flows are going. Now, in this example, if I go to the namespaces tab, I can see that I've got a namespace called company with a child namespace called team. I also have a system namespace, which is normally where we put the flows that manage Kestra, maybe syncing stuff into Kestra, running alerts and so on. Now, if I go to that company.team namespace, in here, I can actually add a lot of different things. I can see these are the 4 flows I have and which ones are dependent on one another. I can store variables such as with the key value store. I can add secrets and so on. I can also edit files. So if I add any files to Kestra, which I've done here, I can access those files inside of my namespace. So when I go to my flow, I can actually access Python files that I've written inside of this namespace in here. So it's very convenient if you've got multiple flows that are maybe using the same Python files. You put them all in the same namespace. It's almost like if you put them all in the same folder on your local machine. Hopefully that makes sense. Cool. So let's go back to our example. So I'm going to get rid of all of these in here, and we're going to add some code. Now, Kestra has these things called script tasks, and I'm just going to type script dot. And as you can see here, and I can actually make that wider, we have a bunch of different script tasks. Now, the one I'm going to use to start with is the Python scripts task. And I can simply just type, and we can again use that documentation on the right to help us out here. I'm actually going to just copy this example. We're going to just grab that like so and paste that in. And as you can see here, what I've got here, I actually prefer to put this at the top because in my head, the way I think about this is that Kestra is running before commands first, then script. So I like to put before commands first. So here, what I'm getting is a Python environment. It's going to basically just run it in a Docker container that's using the Python image. So pretty standard stuff. It's going to use before commands here to run any pip installs or any other commands that you would typically run before actually running your code, whether that's in virtual environment, pip install, anything else like that, that goes in before commands. And then when you get down to script, this is where I can write all of my Python directly inside of my YAML workflow. Now, you might be thinking, why the hell would I want to write my actual Python code inside of YAML? Now, there are a few benefits. It's useful if you only want to write a couple lines. Maybe you want to make a quick request, maybe do some data manipulation, something that only takes a few lines that you can then get the data out response from and carry on. So this works very nicely. You can also use the Python commands one. So what I'm going to do is I'm going to copy all of this like so. We're going to create a brand new file here called requests.py. And I can paste this file straight in here. So its formatting is very wrong. So as you can see here, we're using the Kestra library. We're importing the requests. making a simple HTTP request to Kestra, getting the status code, and then we can send that as an output back to Kestra. So I can then use that later on. Now, if I go back to the flow here, because we're going to use the commands task, I'm just going to get rid of that script and type commands in here. And as you can see, just like that, I can now add in my commands. And all I'm going to do here is simply type Python and then what did I call it? Requests.py, just like I would on a local machine. And I can write any command here. So if you've got maybe something that's you're building your Python scripts a bit differently, maybe you've got a bigger system, any commands that you would typically run on your local machine, you can do that here. Now, there's one extra thing I need to do, which is allow this task to actually see my namespace files. By default, it can't see them, which is good from a security perspective. You don't want any task accidentally writing and deleting and modifying files. So here, what I can do is simply type in namespace files, and then I can type in enabled as true. I can also specify only to allow certain files. So I could also put include, and I could specify requests.py. So if I was to actually just run ls in here and execute this quickly, you'll see that it's actually going to only see the Python file. Hopefully, once it's building a container, so you got to give it a second to pull that image. There we go. It's installed out, and as you can see, you can only see requests.py. I will make that a little bit bigger for you to see. So with that in mind, what I'm going to do now is type in my Python requests.py, and what we'll see now is when I press execute, it's actually going to execute our Python code just like this. It's very unhappy with me. I wonder why. I don't know why it's unhappy with me. It's very unhappy with me. What a shame. From Kestra, import Kestra. Kestra.outputs. Looks good to me. Let me read that error message one last time and have a little look. Oh, I've pressed edit. My bad. But as you can see, the debugging inside of Kestra is also pretty neat. Cannot import name Kestra. Circular import. It's because it doesn't recognize the blimmin' capital letters or something like that. Let me bring up my backup example that will help me figure out why it's not working. Give me a second to dig it up. I have a dedicated example just for a scenario just like this where it's not working. In fact, for this example, we'll get rid of that and we'll get rid of that just for simplicity's sake. So now if we execute it, I'm very confused. No idea. No idea what's going on. I think it's confused by the name of my file, to be perfectly honest with you. So I'm just going to rename this to example.py and then name that example.py. And we're going to press save and we're going to press run. I think it was a little bit confused by the name of my file because I'm importing requests in a folder file called requests. Anyway, let's put in the Kestra thing. So from Kestra import Kestra like so. And if we go back to our flow and go back to here, we can actually see that I can't find the example I had. Let me just quickly go back to our Python script like so. Nick that example because I quite liked it. That's what I wanted. Get rid of all that. There we go. So now what we can do is when we run this, we saw last time it printed it to the terminal to say response.status code. Now, if I execute this now, because of the fact we're using the Kestra library, what it's going to do is it's actually going to output that to our logs. So 200 will now appear in the outputs here. So I can see here under vars that I've got text, but I can also see the status code, which is really, really helpful. So now I can actually use that later on. So I can actually create a new task called log. And what I can do here is actually use an expression to access that value dynamically. And I can access it by doing .python, .vars, and then we know that it's called .total. I actually don't know it's called .total. We'll double check. It's called status. That's what it's called. So we'll go back. We'll do .status. And now we'll see that when I execute this, we'll see that it's going to run my Python code. It's going to run it like we would expect, just like so. And we can see here in the logs that it has successfully printed out status code. So this gives you loads of flexibility to be able to use files that you've got in your namespace files that you can access that way. And then you can execute them here in your Python task. And then you can also then use the data generated by the on, which is much more convenient if you're writing a lot of code that's going to be a bit hard to manage inside of the workflow, or there's multiple files that interact with one another. Then this is definitely the approach you want to take. Now, I'm just going to have a quick look at the chat to just sort of get an idea on where we're at, make sure we're all on the same page. And then I'm going to show you a few different languages and how you can integrate those. Because as you may have noticed, there's a lot of different programming language types. We've got plugins for Python, Node.js, Shell, PowerShell, etc., Julia, Ruby. But that's not everything. And when I say we're language agnostic, I really mean it. I'm not just saying that for marketing buzzwords. I really mean it. So let's have a quick look. Can we run a script which is not in our namespace folder using the syscommands keyword? The answer is yes. Yes, you can. I actually have just created a guide on it that I'm going to bring up in the corner. Give me a second to find my guide. The guide got published on the website about not very long ago. So here, if you're running Kestra inside a Docker, you will need to create a bind mount to be able to map that file directory on your local machine to your container. So in this scenario, I'm on a Mac, so user / my username, which is wrussell /documents, and then I have a folder called files. I can map that inside of my container to /files. So now if I go into Kestra, I can access anything under /files. So if I put any code in there, any files, and so as you can see here, I can access that. But the key difference is I have to change my task to, instead of using a Docker task runner, which is using by default, it's running everything in a container. It isolates all of your dependencies, therefore meaning that you can prevent any clashes where different tasks are installing different versions of the libraries and so on. Just makes that a little bit cleaner. You can use the process task runner, which will just simply run it as a sub-process on your Kestra instance. Now, that's very, very useful because it means you haven't got to spin up a whole container. It's a little bit quicker usually to get started, but then you lose the benefits of having a container. So you'd often want to use a virtual environment here, like if you were running it on your local machine. But as this example shows, you can now access files on your local machine too, because you're not in that container. So one of the benefits there is if you've got a bunch of local files where you're writing your code manually, you can then access that inside of Kestra in this method. So I definitely recommend checking that out. Okay, let's have a look at, can we use a custom Docker file and set up Kestra run as a GitHub action? Does it connect to GitHub repo? There are loads of different ways to do that. I'll get back to that later in the webinar. I'm going to show you a few more simple examples, and then I'll show you how to integrate all of your code with Git, as well as GitHub Actions. You can't run Kestra in GitHub Actions per se, but you can use the Kestra command line interface to run commands such as deploying to your Kestra instance, validating that Kestra flows are in the correct format, and uploading namespace files and whatnot inside the GitHub Actions. We actually have two actions on the marketplace, so check those out. We've got a validate one and a deploy one, but you can also run any of them if you like, any of the commands as well. Someone asks, can we run a custom Docker file? The answer is yes, you can. Now, there's actually a couple of ways you can do this. And again, I'm going to go to my cheat sheet I don't like having a cheat sheet, but it is quite beneficial, especially where I get these questions that I didn't plan for, but I have planned for them because I know there is a solution. So we have a guide. I know there's a guide for everything. I've been working hard on these guides. We've got a guide on Python dependencies specifically, but this will work for anything. Now here, what we can do is you can actually use the Docker build task inside of Kestra. Now I can actually demonstrate this to you by going to here, going to flows, and then going to container image build. Now here, I'm using that Docker task runner again, and I've got a simple script task here that's just, getting a CSV file, processing it with pandas, and then generating an output that we can then access later on. Now, to do this, I want to use pandas and Kestra. Now, instead of using the before commands to be able to install those, what I'm doing instead is building a Docker image that is based on the Python 3.10 image. So I'm kind of doing what the Python environment's doing here. I'm giving myself a Python environment by using the Python Docker image. I'm running pip install inside of my Docker file to install Kestra and pandas, and then packaging that up. And then I can use an expression to access the Docker file or the Docker image that's been generated as an output in my next task as an output. So you can see here, I've specified here, my container image is the output from that Docker build. So I can then build images exactly how I want, pass that down to my Python task and run it that way. But you can also upload these to registries if you want. I'm not going to do that because I want it all to run inside of Kestra. So I've set my pull policy here to never. So it's never going to try and pull from a repository or a registry that doesn't exist. Someone asks how to store API JSON data into an output file in Kestra in Python. Well, I would recommend ignoring Kestra. The key thing here is take Kestra out of the picture. How would you store a file? How would you write a JSON file in Python? That's first step. Second step is once you're in Kestra, you want to, this is where my next example comes in very nicely. If I just minimize that. Okay. So in our Python guide, actually, we're not going to use the Python guide. We don't need the Python guide. We're better than the Python guide. Going back to my original example, what we're going to do is generate a file using Python. Let me do that now. So here's another example. I'm going to go back to this one. Create a new flow. And here I've created a new flow called Python output files. Now here I'm using a script task again. I'm installing requests with before commands. I'm doing it in a Docker task runner using the Python Slim Docker image. Now, if we go down, I have a property here called output files. Now, as you can see, output files here is specifying that we will generate a file called downloads.txt. Doesn't necessarily mean there will be one. It just means that we're expecting to see one. Now, if we look at this Python code, we can see in here that I'm going to make a HTTP request to Docker Hub to get some data. And then I get a response.json, which I can then, do some stuff with. And down here, I'm writing the output to a downloads.txt file, just like you would on a local machine. Kestra isn't doing anything special here. But the key thing is the task is set to capture that file. So someone who was asking about how do I capture API JSON data, this is a fantastic example. We're getting a JSON. I'm then saving it, in this case, to a text file, but you could save it as a JSON file if you want. And then I can actually access that later on down here. So as you can see here, I'm actually accessing that as an output down here, all thanks to the fact that I specified an output file. So now if I execute this task, you'll see that it's going to build my Docker image. It's going to generate that file, and then I'm going to be able to see the response of it inside of my next task. So hopefully that allows you to do some pretty cool stuff. We'll let that run. Let's have a look at some other questions, and then I'm going to jump into other languages. So here we can see that it generated the file, and we can see that it did print out the response. We'll go to logs to see that. Here, that's the number of downloads, I think, is what it's trying to generate. We can see the file here as well, and I can preview it as well. So that's how you would manage files as part of the script task. You can also do input files. So a good example of this would be here, I'm actually accessing that file in a commands task, but I could actually completely remove that and just type downloads.txt. And I can actually just like import it straight into it by using input files. So here I can do input files like so. And then I can type in downloads.txt saying, I want a file called this, and the content of it is going to come from my output metrics. And I'm going to put output files and then downloads.txt. So I'm using that expression here to effectively pass it in as its own dedicated file. And you can actually see that if I type ls as well, we'll see that it's going to see that there's a file in there and then run it. Whereas the expression is injecting it in once it's running, if that makes sense. So here we can see if I scroll down, it can see that there's a file in there called downloads.txt and then the name. Whereas if I was to go back to the old way of doing it, so we get rid of the input files like so, and I now type ls, we'll see that actually what's going to happen here is it's not going to know that there's any files there. It's just going to magically find out thanks to the expression. All of the calculations are happening in the expression. So we go to logs, we can see that it doesn't actually know. It has this temp file, but like doesn't really know anything about it. So that's where this comes quite in handy for managing input files and output files. So we've covered how to run script tasks and with command tasks. We've covered input and output files. We've covered dependencies. Let's run something that isn't Python. We love Python, but let's run, I reckon we should run Go. Go is normally a good fan of mine. I'm trying to work out if the example I prepared is Go or if it's actually something else. Write code in a separate. Here we go. We'll write. I do like Go. What kind of programming languages do you to write with? I'm going to find Go as my next example. Let me find that now. Yeah, what programming languages are you all thinking of using for the hackathon? I'm curious to sort of gauge what people are using. I'm trying to find Go. Begins with a G. There you go. Please try Golang. Fine, we'll use Golang. I can also show you JavaScript, but we have a plugin for that. So my next example is writing Go. Now here, I'm going to use the commands task. I will also show you an example of how to write Go directly inside of I'll also show you how to write Go directly inside of your YAML as well. So here I'm using this shell commands task. Now, the cool thing about shell commands is it gives you a Linux environment effectively where you can now run any shell command like you would on a Linux machine in a terminal. Now, to make sure I've got the right dependencies to run Go, I can use a container image. Now, I can either use one that's readily available, such as the Golang image, or I could build one with a Docker file that has the correct dependencies and build tools I need to use that. So, for example, if you're using C, you need to be able to compile your code and then run it. Whereas Python is a... what is Python? Not a compiled language, the other one. Interpreted language, that's the word I'm looking for. As an interpreted language, you don't have to build it. So with Golang, what we're going to do here is, oh, not like my screen share had a moment there. What we're going to do here is we use namespace files set to true, so we can access a file, and we're going to run a simple main.go file. Now, again, I'm going to keep this really straightforward, and I'm going to just call this main.go, like so. And then I'm going to save that here. So it's just going to simply just run hello world. If I now go back to my flow and we run this, it's unhappy because I don't know. Anyway, when we run this, we'll see it's going to now pull a Golang image. So we've got a correct environment for running Go. And then when I run Go run in the terminal, it knows exactly what that means because it's readily installed. So very, very useful. Someone wants C++. I'll show you C. I think you can join the dots for C++. All right, so here we go. It's pulling the container. It normally takes a little bit longer that first time when it pulls the container. You know what I mean when you've used Docker. And here we go. We can see it says hello world. So if I go to the logs, we can see it does say hello world. Very nice. Now you're probably wondering, this is cool and all, Will, but how do I, send outputs? There's no Golang library for Kestra, so how do I do that? Well, don't worry. I've got you sorted. I'm also going to show you a different example here that's going to show you how to write an input file. So here, What we've got, and I bet this is not going to be very happy with me. There we go. No, didn't want to work. Fair enough. Didn't think it was going to work. That's fine. We can make this work. Doesn't want to save it. It's fine. I can hack the system. There we go. Okay, so it didn't like me changing the ID of the namespace, you see. That's the problem. So what we've got here is we've got the same as before, task runner set to Docker, Golang image, pretty straightforward. Now we have an input file. Now this input file here is saying for main.go, which is what we were using over here. But we won't be able to access that because namespace files is not enabled. So it doesn't know about any of those namespace files. As far as this task is aware, they don't exist. All that exists is the input files here. And we're specifying that there'll be one file inside of this container called main.go. And we can just write it in line here. And because we're writing it in line here, we can now actually write expressions inside of it. So if we wanted to, in fact, I will just create an input here. So we've got inputs. I'm going to create an ID and I'm going to just call this name. Name has a string type. Oh, not if I can type. There we go. And we're going to just set the default value to my name, Will. Now, let's say we want to print out to the terminal. What we're doing here is using this double colon syntax to be able to generate it as an output, something that Kestra's logs will look at and go, I know what that is. That's an output. I'm going to capture that and you can use that in a later task. Now, I'm going to change this because we've got test is a value, but test is not going to be a value. In fact, test is going to be an input like so. So now when I execute this flow, we'll see that my name, if assuming I've written this correctly, is going to hopefully appear inside of the output. Exit code is 0. That's a good sign. If we go to outputs, we can see here in vars, perfect. It's created an integer, a Boolean, a test with our input. So we've actually put an expression inside of an expression, sort of, an expression into what was being generated as an output, which we can see here, and then our flow. So I can then now, using Golang, go into our next task, which in this scenario is going to be a log. And we're just going to log that, and then I can put a message in quotes that basically just accesses that the Go has an output called test. And we're going to see that my name, or hopefully that worked. I'm using a develop version of Kestra. It's a little bit hit or miss. But if you're using the latest, I'd highly recommend that. Much more stable. Cool. Okay. I think we're in for a good one. Any other questions while we wait for Will's Chrome tab to stop having a moment? Let's try again. All right, we're in. I'm going to press execute this time. I didn't save my last task. That's annoying. Let's try that again. Okay, so we're going to do the outputs go.vars, and then we know that it's called test. As we can see, it's called test here. We've had to use a few backslashes here to escape the quotes. Not all programming languages will need that. We do have information on that on our website. I'll put that in Discord. So here we can see that our log message has said will. So we know that the output is being generated correctly. If I have dependencies like net/http, how do I allow Kestra to install it before go run main.go? So what you can do is, because these commands is accepting a list, you can run previous commands prior to it. You can also run before commands too. So you could write before commands and type in, I'm no Go expert, but go install tidy. Is that a thing? Tell me, we will live code this together. And then we can see that when I execute this, it will run it in the before command. So you can be absolutely certain it's installing it. I don't have a go.mod file. That would do it. Yeah, I guess you need to have a file with your dependencies in it, but you get the idea. You can run any command that you like in before commands and they'll be ready to go in your commands. So that's one way to do it. Output files is exactly the same. You would just specify an output file and just write it to the system like you would before. What other cool things can we demonstrate with Kestra? That's what I'm going to show off. Cool. If you do have any questions, though, I'd love to hear them. Hopefully, this gives you a pretty good idea of how to use Kestra. I'm now going to do the forbidden thing and run some C code, which I know is everybody's favorite favorite thing. All right. The question is, can Will remember how to write C code? It's been a while. I'm not saying I don't know how to write C. It's just not something I do very often. Someone actually asked for C++. We actually do have a C++ example, so you're in luck. I'll show it to you. I'll show it to you. It's not very good C++, but it's C++ nonetheless. So this is looking for a file called what? Hello world.c++. It's just a very simple hello world. Don't expect anything more right now. And then again, we're using that container image GCC. We're then able to enable namespace files so we can see it, and then we can compile it with G++, and then we can run it as the out file. So here, if I execute this, we'll hopefully see that it's going to start building that container. It's thinking about it. Again, it takes a while. Here we go. That first run is always a little bit slower. Someone wants to see a Node.js example. Absolutely, we can get a Node.js example up and running in a minute. We've done C++, we've done Go, we've done Python. As you can see here, it gives us the hello world as we would expect. So very, very handy. Node.js, we want a Node.js example. Do we have a Node.js example? Yes. Yes, we do. We actually have a whole dedicated guide on Node.js, so I'd recommend checking that out. Probably quite useful for those of you who are trying to use Node.js. All right. I am going to write Node.js as an inline file. Okay, so here I am using the node script task. I can use before commands again here to install packages using npm. And then I can also specify a container image specifically to use node. Now, here's the interesting thing. All of these sort of specific script task plugins, such as the Node one and the Python one, they're basically just using a Python image by default or a Node image by default. They're kind of no different to the shell commands one. So in this scenario where we're doing script, the only thing is they give you the benefit of being able to write inline natively, but and they know that it's a JS file. But if I was using commands, all it's doing is by default setting container image to a Node image. And having some of like npm installed already and so on. Whereas some of those, you might have to install those or set a container image with the dependencies and vice versa. Now here, this is again doing a similar thing to earlier of getting that data from Docker Hub and generating a JSON for it. And we can see that it's going to print out to the terminal the number of pull requests. So if I execute this now, we'll hopefully see that this is going to execute. Now the key thing is, this is not going to run your web server. Just making that really clear. For those of you who are looking to build web servers that will interact with Kestra, this is for running something sequentially. It's going to run from start to finish. Maybe, it can obviously branch out, be parallel, whatever, but it's not something that's going to run non-stop. Haha, npm needs to be updated. Shocker. But it did print out our answer. So do bear that in mind, that we're not expecting this to run continuously. Is there any way to create flow without using the UI? Could you clarify what you mean by that exactly? Because I am using, I'm writing it using YAML, if that's what you mean. If you mean like not using the Kestra instance, then you can 100% use your local machine. You can write it there with the VS Code plugin. And then you can upload it to Kestra using the API or the command line interface and execute it without even having to touch Kestra, if you would prefer to do it that way. I don't know why my enterprise edition is very slow, but we'll move back to my open source one. Open source one's good. What we're going to do here is show off one little thing. So here, oh wow, my whole computer has just come to a grinding halt. I do apologize. Oh, I found the problem, everybody. Docker has turned off. I don't know why. Okay, give me a second to figure that one out. The entirety of Docker for desktop has just shut down on me, the whole thing. So we will try and figure out why it's done that and get back to you shortly.
Yeah,
Now,
till
what?
till you figure out Docker, maybe I'll plug in about registrations and
Yeah,
some
do
updates.
it.
Yeah.
Do it.
So folks who are there in the stream, if you haven't already checked out for the contest or prizes, right, you can maybe take out a screenshot from this webinar itself and share on your socials, and use hashtag hackfrost2024, tag Kestra, tag us, right, and share what you are building, your project ideas, maybe how you are looking forward to implement Kestra in it. And you can win some cool swags. Will be able to show you the swags because he's the right person. And
I have got the swag on. Is that what you're after?
yes.
I also have the hoodie. The hoodie is in typical programmer fashion on the floor. Yeah, there you go. You can see it's got this very nice stitched Kestra logo on it.
Well, I would not leave that chance to grab that or grab my hands on that today. So make sure Sarkestra on GitHub. They have also launched on Product Hunt, and they are on the second number today, if I'm not wrong.
We were second. Hopefully, we're still second. Yes, comfortably second, still far away from first. So hopefully, you can help us fix that.
Yeah. Feel free to share about the tool, and I'm pretty sure many folks have already tried Kestra, so they might have good opinion around Kestra. So, Kestra folks would be able to, or they would be excited to hear about that. So is Docker up and running now?
I think so. I just
Yeah.
it's yeah, my enterprise one is not, but this one is. So we'll use this one.
So I guess back to the demo.
Here we go. Now, oh wow, look at that. Kestra's live on Docker Hub. Would you on Product Hunt? Would you believe it? Someone asked a really good question actually, which is a good segue of why would I want to run these programs in Kestra? Can you give me a real world problem that's solved by Kestra so we can better understand the importance for it? Absolutely. The thing about Kestra and just generally orchestration in general is that there's nothing stopping me just going to my terminal and running all these things or running all these things as a cron job. Cron jobs are very helpful, but you start as you scale and you process more data and run bigger pipelines and run, code that's much bigger. It gets harder and harder to manage. I'll give you a sort of a real world example where I experienced this in a previous job. I was writing a Python script to process data scraped from the GitHub API. Now, originally, this wasn't very big and complex, so I just ran it as a simple cron job in a VM on DigitalOcean. I had DigitalOcean running it every 4 hours, so 6 times a day. And it was pushing all the data into a spreadsheet that they can be used by non-technical users. My system's just gone into dark theme. So because of that, the issues I was running into was when it crashed, I had no way of knowing that it had crashed. Whereas with Kestra, I can set up alerting that says if it fails, notify me on Slack. And so it also made it quite difficult to debug because if I gone out of focus or my eyes just going funny, I think my eyes are just going funny. There we go. That's better. So the problem I found with it was that if I had an error, I didn't know that I was having an error until I noticed that my spreadsheet hadn't updated. Going through the cron job to find the logs was not easy. Whereas with Kestra, you can really make it much easier to just quickly jump in, press on your execution, filter by logged level, and straight away you can see the problem. The other thing was sometimes I wanted to run manual executions, which would require me to SSH into my VM, go to my directory. I had a shell script set up that could smooth out the process and then run my shell script, which would build the virtual environment and run my code and then build it down. And I found this very frustrating because it would crash and I wouldn't know why. Normally because the GitHub API would rate limit or something. And that's the sort of thing where being able to receive those alerts in Kestra would have been a lot easier. And especially as that operation scaled, we didn't just run it once. We started running it for different scenarios on GitHub, not just one. It expanded to running in different scenarios. So in that scenario, that's where inputs would be very helpful because I could pass in and say, this time I want you to run this one. This time I want you to run that one. And I could run different schedules at the bottom of my pipeline with different inputs to say this schedule is for, the first stage, this schedule is for the second stage, this schedule is for the third stage. And I'm obviously just an individual writing this code. A very common use case for Kestra is if you're a big retailer who's got tons of stock, loads and loads of different items from different stores all across the country. And every time someone makes an order, you want to be able to update that stock and make sure that when stock's going to different locations, you know about it and whatnot. And that's where you've got a lot of scripts that are just processing this data, but you need something to like manage all of these scripts and tell you when certain scripts are working and when some are dependent on one another and vice versa. So it's when you start to scale that operation that you need something like an orchestrator to help you manage all of that together. Now, I agree. Running a simple hello world example in Kestra is a little overkill and definitely something you could just do in your terminal. But hopefully, this gives you the building blocks that you need to be able to build interesting things, more advanced things. A few use cases are that some people, some users we work with use the API extensively to be able to build their own separate user interfaces to interact with Kestra, where they only want to be able to, tell it to run when certain things, for example, like we made the example earlier of if you have an online shop, maybe you build an online shop for the hackathon, and when you place an order on your front end, it tells Kestra to run a Python script that's going to process that order and change the CSV files, update the database, all those sorts of things. And the key thing about Kestra is it can do all of these things at the same time, and you can set it up to scale really nicely. So hopefully that gives you a bit of an overview of Kestra and why you would use Kestra over just using a cron job. Now, if I press save here, jumping back to our Node.js example, because I know someone really wanted to learn a bit more about this. Here, I have got a task called run Node.js, and it's going to be a node commands task. So this time I'm going to have to create a separate file. I've got namespace files enabled, so we know that it'll be able to read the file once it exists. And we're running it in Docker, so we're using that Node Slim image. Now, this time, I'm actually going to install the Kestra Node.js library, and this will allow us to be able to generate output files. Now, let's open up a new file. I need to remind myself what the file is in, what it's called. It's called outputs underscore node.js.js. Looking at it's in the corner there, and it's going to have this code inside of it. Now, as you can see here, we've got a simple function that's going to make an API request using requestify to get the JSON response that has how many pull requests have been made. How many Docker images have been pulled from Docker Hub. And then what we're going to do is generate using the Kestra library an output where we're just handing it an object that we'll be able to see in Kestra. So now if I press save on that and we jump back over here, we'll hopefully be able to see that output generated at the logs. So here when I press execute, we'll see that it's going to start to execute our workflow. It's going to start to run it. Node.js is having a mare. We ignore Node.js. Oh, it doesn't like something. It's had an error. It's had an accident. Very, very interesting. There's a good chance that the Node.js library is changed a little bit since I wrote this example. Should work exactly as I would expect. So output underscore Node.js. We'll see if it runs. While we wait for this to run, has anyone got any other questions? I'd love to be able to answer your questions. We've got about 10 minutes left. I'd love to, understand what's going on here. Ask your questions. Module is not defined. Interesting. Import. I'm not a Node.js person. Can you tell? What I'm typing import here, you reckon? Or do you mean over in required? It's all down to Will not knowing how to write Node.js at the end of the day. We'll see. We'll go back to that error message for a second. can we declare environment variables? So we'll skip over this example because I clearly can't get it to work. But what I will show you is how you can access dynamic properties inside of your workflows. Now, I recently wrote a guide on this. I know I've written a guide on everything. Shock. Let me grab that up and we'll use that guide which has a pre-made example inside of it. So example number 1, I have an inline script where I have an inline code, Python here, written directly in line. I'm able to use an expression to hand my input here directly to the code. Very, very helpful. But there is a sort of slight dilemma with this, which is that if I want to use a namespace file or a file on my machine, my camera is auto-focusing weirdly again. It means that I can't do this because if I write that in my Python code, Python's going to sit there and think, I have no idea what this is. I've never seen this in my life. This is invalid syntax. So what you can do instead is use an environment variable. So how do I declare environment variables? Very, very straightforward. Let's go. So we'll create a new workflow. In this new workflow, what we're going to do is generate the exact same example, but we're using the env property here, and then we can just specify key value pairs of our environment variables. In fact, I can create a new one called my var, and I can just call it hello, like that, hello world, just like that. I can create myself a namespace file called main.py that's got like so. Ooh. So we'll create that. We can paste in here. And as you can see here, I'm able to access that environment variable. And there's multiple ways you can access environment variables. Any way that you would typically do this on your local machine, you can access that, and then I can access it here. I can also do print os.mron, and then I can do my var, like so. I can press save, and then I can go to my flow. When I execute this, I got my URL here, and we'll see that it works. When it builds the image, it's going to put those environment variables. We can see that what it's done here is it's got the hello world example. Now, interestingly, print the content of the page. Yeah, it definitely did that. It definitely printed the content of the web page. Just what we needed. But we did get to see the environment variable, which is the key thing. So that's one nifty way. And the reason I like doing it this way is as soon as you want to run it on your local machine while you're writing the Python, you can obviously just pass in those variables as environment variables. So it works either in Kestra, where you've got it deployed, or you've got it working locally. To kind of go back to someone's question of like, where would I use Kestra? If you want to deploy a script to run in the cloud and you're going to run it in cron, that's where Kestra comes in very handy as your sort of production environment for being able to run it in a slightly more sophisticated sense, especially when you have multiple people running it. As you can use multiple users in Kestra, you can see audit logs, you can see who's executed what. So it makes it a lot easier to manage when you start to scale up. As an individual, I think it's still a really powerful tool for being able to just tell something to run and then get notified. For example, I have a local club that I'm involved with that wants to be able to sync a spreadsheet with a calendar on a website. Kind of janky. And I'm thinking, how could I do this? I could do this with a Python script, and I can then just have that Python script run inside of Kestra using the open source edition. And then I can send myself a Slack message if it breaks, or a Discord message if it breaks. So I can sort of keep in the know that it's working, but I can sort of ignore it. And if someone goes, oh, we need an update now, and it's running daily, I can go and press execute manually. And I can do all of that from my laptop without having to run it on my laptop. I can just go to the URL of my server, or in my case, a Raspberry Pi, and it works. Cool. We've got about a few more minutes. I'd love to hear from the rest of you. I think my enterprise, here we go. This is the one I normally use. I'd love to hear from you all in the chat. Any other examples you would like to see? Anything else? Yeah, I'd love to hear what other examples people want to see. Any other questions? Otherwise, we'll start to wrap up, and I'll keep an eye on Discord.
I had a question to you, Will. How much time will it take for me to automate, maybe or create a workflow wherein if folks ask questions regarding Kestra, on Discord that would directly ping you?
So the way you'd have to make that work is you would need some sort of Discord bot running separately to Kestra that would be basically monitoring the channel. You can do this with discord.py, where it can be staring at the channel, and anytime there is, it's called an on message function, and then basically you'd have that on message function forward everything to Kestra using an API request or a webhook, and then you'd have a workflow with a webhook trigger, and then that's where you could then forward the content of the message as a Slack message to my Slack instance. Or you can email me. That's also something you could do. Email me with it, or both. If you wanted, you could just do all of it at the same time in parallel. So I'm getting spammed in every direction. But the key thing is that Kestra, I mean, at the moment, maybe someone could build a plugin for Kestra that is able to look at Discord messages as a real-time trigger or a polling-based trigger. That could be cool. But yeah, there's no way of being able to poll the Discord channel with Kestra. But if you had a separate thing just polling it, then you could send an API request to Kestra and then get Kestra to run the rest.
So is this a winning idea?
I mean, if you can pull it off, especially if you can build a plugin to do the Discord bit, I would be really impressed. If anyone builds a dedicated plugin, that would be crazy. For context, Kestra's written in Java, so the plugins are all written in Java too.
So, folks, I have brought a winning idea for you. You just have to implement it. And don't
Yes.
ask me for help, definitely.
Oh dear.
So,
Yeah, if you do that, that'd be cool. Do it.
so we have, I guess, few more questions. We'll take that and then we'll end it. Okay.
Perfect.
So is there an SDK available for Kestra?
Is there an SDK available for Kestra? Great question. There is not an SDK available for Kestra. But we are looking at maybe building some in the future. We have talked about maybe building like a Python SDK where you can do a lot of with Kestra, kind of like you would with like Apache Airflow, where you write all of your code and then you can interact with it a little bit more natively. But if there's something you're interested in, go and upvote it on GitHub. I think there's a GitHub issue for it. So yeah, would love to see it.
How? Okay, you can go ahead and read it.
Sorry. How can I better the ML model deployment automation, and how should I submit it like full stack? Like ML model had to be retrained after data is changed. Now I'm no expert at ML. I'll be honest with you. However, what I would do is, if you have a workflow that can detect event-based wise when data has changed, maybe you're using a real-time trigger on a database or a data lake or something like that, and you've detected that there's been a change in data, and then you can start a workflow that will then start your retraining process, assuming it's a Python script or something. You can also use something like Modal to run your Python script. We did a webinar with Modal recently where you can use their pretty cheap GPUs to train models and LLMs pretty quickly. So yeah, a webhook would be a good way. If you can have something trigger a webhook, then Kestra can get started at doing what you need. So I think that could be a good challenge to figure out over the weekend. And someone asks, what is the updated version of Kestra? So the most up-to-date version of Kestra right now, if you were to go to Docker Hub, which I don't actually know what the URL is for our Docker Hub, so I'm going to cheat and go to our docs and go to it on Docker Hub. It's on Docker Hub at, we'll find it and then we'll wrap up. I promise. Here we go. We're on Docker Hub at Kestra/Kestra. Our most up-to-date image is obviously developed, solid. It's 19.12, but V0.20 comes out next week, which is what I've been using a lot in my demos today, is the snapshot edition. So it's a bit buggy because it's a couple of little bugs I've got to fix, but yeah, the next version of Kestra comes out on Tuesday. Just use latest. I'm using develop. Just use latest.
We'll take this last question. Will we get prizes if we are out of India? I definitely will get it. Since this is a global hackathon, if we get winners out of India, they will also be receiving the relevant prizes. And before we wrap up, just few things you folks should be aware of is, first thing, registrations will be open till the end of the hackathon. If you haven't already registered, please make sure you register. Every team member from the team has to register. Also, check out all the relevant links which is there in this, in the description of this webinar or this video. Kestra has also launched on product end. Make sure you support them. And if you are already not on our Discord, make sure you join our Discord server, because all the queries, and we have our Discord community call as well tomorrow, so you can join in and get notified or get updates regarding this hackathon. I guess that's it. Check out hackathon website for any other details. That's it. Yep. Also share about this webinar on your socials. You can get chance to win amazing sacks from Kestra, t-shirts, hoodies, pens, and stickers. Make sure you utilize this chance and build something great. We have been getting a lot of queries, and we are excited to see what you build. I guess that's it. And thank you so much, folks, for joining. Make sure you start Kestra on GitHub as well. Bye.
Awesome. Thanks, everyone. Bye.